So this is exercise 3.1a, question 10. And it says show that the sum from r equals n plus 1 to 2n minus 1 of r is equal to this thing here, where r is some number that is greater than or equal to 2. Okay, so just to remind ourselves about the formula in terms of arbitrary n, so the sum from k equals 1 to n of k is equal to n times n plus 1 divided by 2. So that's what we've already worked out so far. Okay, so let's write this sum here. So the sum from r equals n plus 1 to 2n minus 1 of r, that's actually equal to the sum from r equals 1 to 2n minus 1 of r minus the sum from r equals 1 to n of r. Because if we go from 1 all the way up to 2n minus 1, and then we subtract from 1 all the way up to n, we will be left with from n plus 1 to 2n minus 1. That sum there. Okay, and then it's pretty easy to figure out what these two sums are. So we just, for this first one, we just substitute n for 2n minus 1. So it's 2n minus 1 times 2n minus 1 plus 1, which is 2n, and then the whole thing divided by 2, minus, and then for this one here, it's just exactly as it's written, so n times n plus 1 divided by 2. And then from there, well, I don't know, we can, it's probably a way cleverer way to do this. We got 4n minus 2 lots of n minus n plus 1 lots of n, and then 4n minus 2 minus n plus 1, so that will be 3n minus 3 lots of n divided by 2. And that's what it's supposed to do. Kind of, we can factor the 3 out. And so that is 3n times n minus 1 divided by 2, which is exactly what it was supposed to be. And that question, I think, is way easier than what I made it look. But, well, I still got to the answer. Okay, so that'll do for question 10. And let's also take a look at question 11 from the same exercise set. And I think we can use pretty much the same trick to solve this one. So the sum from r equals 1 to n of 5r minus 4 minus the sum from r equals 1 to 4 of 5r minus 4. That's going to leave us with the sum from r equals 5 to n. Okay, and then we also have that this is 5 times the sum from r equals 1 to n of r, and then it's just minus 4n, just by splitting up that sum, as we saw that we could do before, minus, and then we'll do the same thing here, 5 times the sum from r equals 1 to 4 of r, and then minus 4. 4 times 4, not just 4. Okay, and then so this is equal to 5 times n times n plus 1 divided by 2 minus 4n minus, and then it's going to be 5 times, so this time n is just 4, so it's 4 times 5 divided by 2, so that would be times 10, and then plus 16. Okay, and then all we got to do is simplify it. So we got 5n squared, and then it's going to be plus 5n minus 8n. So minus 3n. So that's over 2. And then we have minus 50 plus 16, so minus 34, which is indeed equal to 1/2 times 5n squared minus 3n minus 68. Yay for us.